Thank you very much, Pamela. So I'm delighted to join today, and I've been a public servant for, I guess, the last 14 years, and before that started my career in the academic side of things. So it's interesting being on a panel with Pamela. We're not that funny in government, but I was trying to think of a title, and I see engineering as a verb, and I think that's really where I want to go with this conversation. I think the case for why you should care about public policy has been made this morning. I'm going to try and answer Bernard's question around how to do it, how to start, where to get in, and give some practical examples of where I think engineering has made a very big difference in terms of the outcomes from a public policy making perspective. Interesting takes on the definition of public policy making. I won't presume to try and define it other than to explain how it's being operationalized in the Ontario Public Service, and particularly my ministry, the Ministry of the Environment today. But it certainly is a messy place. I see that as an opportunity. It's not linear, it's not very controlled right now, but it does mean that there is no right answer to how to get involved and how to make a difference. There's lots of different ways, and depending on the question you want to influence and the degree that you want to get involved, there's a lot of different opportunities. So I think the messiness is the opportunity from a process perspective right now. So I'm going to give you the insider's view from my vantage point in terms of driving change in organization like the Ontario Public Service, particularly where we have been driven by both, I would say, public servant agendas as well as political agendas. And I think in both contexts, you can see the technical engineering aspect really coming alive. And in particular, I'm going to talk about renewable energy and municipal wastewater approvals. In both cases, very big, challenging, complex problems. A lot of the same themes here around. I think the place where engineering is most interesting, if it's a really obvious, simple problem, there's probably not that much interest or need for the engineering technical side. It's the messy problems that really attract, I think, these kinds of evidence-based questions, and probably are why I think of engineering in this context first and foremost. So just a little bit of context of where we are as a public service right now in Ontario. Our mantra is really the concept of our best advice. And I think this comes from a lot of different drivers, and there's always a flavor to how public service operates in Ontario, and I think this is reflected in a lot of civil servants across the Western world. There's fiscal constraint is the big driver. We're always looking at that. We're always judging our decisions against that filter. And as a result, being able to defend every single dollar that gets spent, knowing that you've agonized over all the possible ways to do this, and this is the best use of that funds, is ever more critical. So there's not a lot of flexibility to experiment on things that aren't truly evidence-based. At the same time, there's a lot of opportunity for continuous improvement. Things like rethinking what the outcomes are, how we measure those outcomes to drive us to get to different places, rethinking the ways we do things. So I think there's a place for big technical input, for big changes. If there's a lot of evidence and a case, I really resonated with that concept around being able to communicate and articulate that case. But there's also a ton of places for smaller change to happen, influence to happen into the agenda that will continuously improve, continuously move forward, because it really is that kind of a context that we're working in. And so the concept is probably less about traditional policy development and more the concept of polivery. And polivery really is policy and delivery. When you're not judging the success of the policy on its own merits, that you will judge it very much related to how it will be delivered. And maybe that goes to the ends and means that Pamela was talking about. I think that is really where we are. We're moving beyond just looking at the policy side and very much looking at how this will get implemented, how it will achieve specific outcomes, what's the action at the other end of it. And as a result, technical advice is very critical if you're going to make it work. So just being a popular idea or implementing a political promise is not really where the success gets measured. It's going to be in the delivery. So the traditional policy program management cycle, in terms of the way we think about things, sometimes, and when I first started in government, I worked in the Ministry of Municipal Affairs and Housing and worked on some really big land use initiatives, like the development of the Greenbelt, work around the growth plan for the Greater Toronto Golden Horseshoe area. And it was a pretty traditional policy cycle. The politicians came to us with an agenda. That policy development phase can go fast or go slow depending on how soon they need that promise delivered. It's often based on tons of information and data historically, what we've known to date, pilot projects, guidance, things that have been done before that sort of feed into that thinking, lots of stakeholder engagement, a lot of a public process, eventually turned into legislative vehicles that implemented that. And then when you get to the bottom end of that cycle there around program development and planning implementation, this phase didn't happen overnight. It happened slowly, often. If you're implementing using a foundation as a steward, or you have municipalities, in the case of a lot of land use issues, you have municipalities implementing it through their official plans and zoning. So that takes some time for conformity exercises to take place and big ideas to then get translated into the local specific technical rules that people operate around. Sometimes it goes to a different ministry or an agency or a different part of the ministry that would work out implementation, and often the legislative framework includes a 5-year or a 2-year window that you're going to come back and revisit, that there's going to be this cycle. So traditionally, I think that's how policy, this is, to me, would be sort of the textbook 101 around how public policy gets made, and there are lots of examples where that still is the case. I would say less and less so. So part of the space for where I think engineering advice can fit in is around continuous improvement. Once we know we want to deliver these kinds of outcomes, but maybe we're not actually getting to the performance metrics that we have held for ourselves as a society, as a government, or maybe there's a better way to do this, a better way to deliver a program, maybe new evidence, new science has come to the fore that would change the thinking, maybe want to adjust the rules. Continuous improvement, and I would argue even in a minority government, is a very effective way to engage technical conversations, go directly to the bureaucracy, have those conversations, because continuous improvement is built into the cycle, it's non-threatening, and it's seen as a very legitimate and often part of the process. But then sometimes, because of political drivers or because of financial impediment, we actually cut straight through and we skip a lot of the policy development, or at least we crunch this, and we go straight to program planning and development, where we need a fully functional program that is locked and loaded in just a few months, or we don't have time to work through a multi-year schedule. We have to get everything done together. When you see those kinds of issues, lots of opportunity for a technical conversation. And I would say one of the best, most recent examples in the environmental space that I certainly have been involved in, but I think stands across the government as a strong example of this, has been the whole piece around renewable energy, green energy. And I'm going to talk about the renewable energy approval because that was the Ministry of the Environment's contribution to that space. But this was a place where we needed a technical, on-the-ground solution fully implemented because the government was trying to get to a very aggressive economic shift in our economy, shift in our the way we produce energy. And so there was no time to invent a policy and then spend a few years figuring out how to implement it. This all had to happen in a very rapid space. And as a result, I think the technical engineering voice was very influential in the way the conversation goes forward. So in case you weren't paying attention and you're not sure what I'm talking about, in 2008, the Ontario government committed to eliminating coal-fired generation. And as part of that, there was a feeling we needed to spur an economic investment in this province as it related to greener options. And so the Green Energy Act was born largely influenced by then Minister Smitherman and his vision with the Premier as to how we would energize around the concept of renewable energy and a clean economy. And so the Ministry of Environment was tasked with coming up with a way to approve these facilities that would cut out a lot of layers and time. So I had heard that renewable energy projects like a big wind farm could get through as many as 50 different approvals at 3 levels of government plus agencies. It was a very complex space. It took years to get a project moving. And if you go back to the cyclical nature of public policy making, this government didn't have 5, 6, 8 years to demonstrate a change. They needed it to happen within a year or two so they could show on the landscape that they were doing something different. So the drivers were very different, and we had to come up with a different process. So we were tasked with finding a way to modernize that approval context, and what we ended up building was something that looked at least the provincial layer of that mess of approvals and think through how do we integrate them all into one process. And as a result, we were also tasked with addressing some of the municipal issues because municipal planning and the local decision making was being eliminated from the process. So what did it look like from a technical change perspective? Well, before you've got multiple approvals, now you have a single approval. So that's getting you, instead of looking at the impact of the project, the technical impacts to the environment or to the community at various points of the life cycle, like through the environmental assessment or through an approval at the municipality, then another engineering technical approval around construction of the facility. Instead, we were assessing the environmental impacts of the project all at once. So we were looking before you submit an application, go off and do a bunch of studies that will assess the total impact of that facility on the landscape. That's a very technical conversation that is now condensed into one process instead of being let's look at the construction and building issues. Nope, now we're going to look at the environmental issues. Now we're looking at the water issues. We were looking at everything all at once and trying to design a process around that. And so these are industrial facilities. They might be cleaner and greener and positioned that way, but a wind turbine is still an industrial element you're putting onto the landscape. And a bioenergy facility is still an industrial activity, and so there's a lot of technical engineering issues related to the way that is constructed, operated, and its impacts into the environment and how they're mitigated. We were also looking at, before, local variations. Municipalities set the rules for the most part. Lots of process at 3 levels of government, but municipalities set a lot of the standards and requirements. Now we were talking about provincial-wide standards. And so those provincial-wide standards, we actually didn't know what they should be. So we spent a lot of time with acoustical engineers and others, to give an example, trying to figure out how would you model noise in order to establish an appropriate setback from a receptor, a residence, let's say, from the wind turbine? How do you come up with a province-wide standard for what that number should be using an acoustical model around a number of different inputs that could impact sound, and how do you model that? And then how do you measure that at the site if you're standing on the front lawn of that house and there are 32 turbines within visual distance, because there are some instances in the province where that exists today? How do you then assess whether or not an exceedance in noise, where is it coming from? How do you figure out which particular infrastructure piece, whether it be a turbine or a nearby stamping plant or a roadway that's causing that exceedance, and how do you then exercise compliance around it? So a very technical acoustical engineering bit of work that was quite innovative was sort of happening at the same time as we were trying to figure out what a province-wide standard was. Because the alternative was we could just take the political answer, which we got on the first day, which was, well, I'm thinking it should be somewhere around here, but go away and come up with an evidence-based answer to that. And then in the absence of not wanting to just sort of take a public opinion poll about what the number should be, which is really what municipalities had been doing, where's the level of local comfort, because it's going to be a standard forced across the province, we had to go back to an evidence-based place to try and come up with that understanding of risk, how we're going to mitigate it, and what the right requirement should be. So a very technical process to develop a specific policy requirement then. You also had before an assessment of project design, construction, operation. It was all done as a site-specific assessment. Every situation was unique. In the renewable energy approval world, afterwards, they were provincial-wide standards, best practices, guidance. It became a very technical, specific requirement on how you would build and construct and operate renewable energy facilities. And it wasn't going to be decided based on a detailed analysis of the way this particular facility was going to be designed. There just wasn't the time. If you wanted to move projects at this pace, the rules had to be upfront, the requirements had to be very technical and specific to address all the issues, but standardized and put up front. So that shift to try and come up with provincial-wide rules forced us into a very technical conversation around how you're going to mitigate risk, whether it be to the air, land, or water, or any of the other natural heritage or cultural heritage. These kinds of issues had to be worked up in an upfront process. And then as the result of that, you got an approval with service standards, monitored against energy contract milestones, so we're able to say that for sure we think we can make decisions on these projects within 6 months. The process becomes more predictable. We can estimate exactly when decisions about whether or not a project would be able to go forward and connect to the grid. We can start making energy estimates around energy production in what time period and at which locations, and it becomes a very predictable process. But requires a ton of technical thinking in order to come up with the policy rules that can get you to that kind of unequivocal service standard. Still creating the binding legal terms and conditions, still the same level environmental protection, just done a very different way. And so probably moved a lot of the technical and engineering work that was being done on a consultant basis, site by site, into a policy-making process to set the upfront rules and requirements. So I'm not going to get into much more detail, but I'll just give you a sense around the pace of change. And I guess that diagram, the circle with the line that sort of cut across, we didn't take a year to go through the policy cycle. You end up with a situation here. We start over here with the Green Energy Act in 2009, and we go immediately into technical requirements for approval. So we have jumped from policy idea all the way to fully implemented system in about 6 to 8 months. Very, very unusual given the concept and what we were trying to do. And then by January 2010, we're already making amendments to the regulatory framework. So we're already changing the rules because there are recognition that some greater clarity needed to be there. This is your continuous improvement. So continuous improvement is happening 1 year later. Meanwhile, real projects have been introduced and projects are already beginning studies. So we are working in a live laboratory, money's on the line, big contracts, big projects. So you're changing rules or adjusting rules in a very live context where contracts were given, proponents were given promises around what they would get. We start program review, which in many initiatives is legislated at a 5-year interval. By 2012, just a few years later, we're already starting a program review as it relates to the feed-in tariff program and the approvals writ large. That spawns 2 more rounds of amendments within a year. So now we're making additional changes. The transition provisions alone make the lawyers squint, but it's really complex, and still these projects, most of them aren't even built yet. So we've changed the rules or adjusted the rules 3 separate times and done a program review, all within the space of these contracts going through the life cycle of their business. Meanwhile, we're developing technical guidance, releasing iterations of technical guidance that tell you exactly how you are expected to meet those bars. So the only way this would have worked is with a heavy involvement of engineering and technical advice, both in the design, in the advice on how to make the changes that happened at those amendment periods, and in the development of the technical guidance to make this work. Because the minute we start coming up with, you know, that's a nice idea, but it isn't going to work in practice, these projects on the bottom, we're going to scream and come back and say, hey, government, you gave me a contract. I don't care what this other ministry's doing. You gave me a contract and I need to move forward. So heavy technical input in that process. I'm going to give you another example because I think a lot of people might say, well, yeah, but that was like a once in a, you know, timeline. You know, green energy is very unique. It's not going to happen again. It doesn't really exist in other contexts. And my experience, and I know that I don't have a typical government job, but in my experience, it's increasingly the case that we are asked to look at things from a preliminary lens, look at policy and delivery together, and move forward in a pretty rapid space that demands technical solutions much earlier in the thinking. So wastewater in Ontario is demanding an integrated approach for a number of drivers. We've got policy initiatives already out there, things like source water protection, Great Lakes protection, concerns around nutrient loading in our Great Lakes and in our waterways, and how we manage that, recognizing that wastewater, whether it's processed water from industry or whether it's stormwater or whether it's municipal sewage treatment, is all factoring into the stress that we have on our water system. We've also got an initiative called the Modernization of Approvals, which is what I lead at the Ministry of Environment, but it's happening in a lot of ministries. Drummond report was another example, kind of pointing to government, you've got to get your act together, you've got to be more efficient. If you're going to meet your fiscal crisis, you're going to have to get a lot smarter in the way you deliver services. So we're looking at things through a risk-based, client-centered kind of service delivery lens, and kind of asking questions. I know we've done it that way for 30 years. Should we still be doing it that way? How do we get the outcomes, shave off the things that aren't really adding value, and really take a hard look at the way we deliver our services? So that's kind of the bigger government context coming in there. At the same time, the federal government and Pamela mentioned that there's probably very few problems that aren't interjurisdictional. We've got this federal factor here. The federal government has come up with wastewater effluent regulations, monitoring requirements, data collection now, monitoring and requirements to the feds municipalities would have to provide. And then by 2015, they need to demonstrate or start to demonstrate in their phased approach that they are actually meeting these new effluent limits, which will a lot of call for can provinces line up with the federal government with an equivalency agreement so that municipalities don't have to meet two different sets of rules. So here's another driver changing the way we deliver the programs, potentially the outcomes we're trying to get to so that we can harmonize with the federal approach, and also impact on service. And then you've got the municipal and industry feedback. They're looking for flexibility. It's a tough times for all organizations. Looking at our aging infrastructure, investments in infrastructure. If you want to change something, the approvals process is a major burden. If you've got to wait 2 years to get your decision out of the Ministry of Environment, that's not an efficient way. It's difficult to manage your finances. Think about it. They're looking for ways to not have to come in for multiple amendments and manage their infrastructure holdings in a creative way. So a lot of drivers for change, a lot of drivers to recognize that this is one of those complex problems. It isn't going to have a simple government can fix it all by themselves kind of solution. So this sort of kindergarten diagram of wastewater. So just to say that wastewater is an extremely complex and technical issue. We've got a number of different things happening. We've got the industrial inputs into the air, land, and water. You've got tons of pipe running all over the place to support our environment, and continually, whether it's condo development and the density pressure, or whether it's greenfield development and new buildings happening, there's all of this infrastructure that's new infrastructure, aging infrastructure, infrastructure that's being adapted, and all of the impacts that relate to that. You've also got municipal treatment facilities and the pressure around meeting growing cities, and how do you address those issues in particular as it relates to stormwater. A lot of environmental issues in terms of erosion or where the points of emission into the water or the land or the air might happen. And so here, this is an issue where it isn't just a water engineering issue. It isn't just an air engineering issue. It is a complex technical problem with a number of different inputs. So when we say, okay, lots of things driving a different approach to wastewater approvals, well, which part of those problems are we going to focus on? Because right now, we're approving things or engaging in compliance activities all over that space. So going back to what are you trying to measure, what's the evidence you're going to bring to this, what are the outcomes you're trying to get to in a financially strained environment and still meet the environmental outcomes you want, that's a very messy space to then try and figure out what to do next. So where does engineering fit in this? Well, I think that engineering will be critical to helping us redesign the ministry's wastewater approval process, because we have a lot of objectives we're trying to get to, and it's a very technical space, and if you left it just to policy alone, you wouldn't get to the solution we need to be at. So where I think some of this analysis might get to, and this is just a bit of a prediction on my part based on research done to date in the space. Well, I gave you the 2015 deadline, so I think the clock's ticking. Consistent operating requirements, leveling the playing field so that the rules are clear no matter whether your facility was built 40 years ago or tomorrow. How do you look at the consistent requirements so we can truly look at the environmental outcomes we're trying to get to? We want consistency, but you also want flexibility, because people I think can understand that it's probably not the best use of government time or resources on the part of industry or municipalities to constantly come in for minor changes, and recognizing that technically these kinds of plants operate in ways that you make changes based on seasons, based on technical drivers all the time. You get an approval that's too tight, you can't do any of that flexible work, but at the same time we don't want a system that's so loose that you get an approval that's meaningless because we don't actually know how it's going to be operated. And a policy alone cannot come up with that answer. That's got to be informed by a technical understanding of how it actually works in a wastewater treatment plant, for example, and how you actually make those decisions in order to determine the kind of degree of flexibility that is environmentally protective but actually smart from a way of the service being delivered. We also want to get to a place that can encourage the kind of innovation. And if we have approvals and processes that are so focused on specific things you have to do, then it doesn't create a space for people to think about a different way to achieve the same outcome. So but then to challenge, well, what should the performance outcomes be? And in a lot of this space, we don't actually have hard standards in terms of the requirements we're trying to meet. So to move from a space where we are very focused on the how you build the facility to a policy discussion around what are we trying to achieve in the regulation of the sector in the first place is a very difficult span of space to traverse, and will require technical engineering advice both within government and outside in order to inform that conversation. Monitoring requirements for a facility, what's the end game long term? How do we collect the right kind of data, make sure we're asking for the right kind of information that can inform either the continuous improvement I was talking about earlier or other kinds of changes to the process. Application requirements in terms of what are we going to base our evaluation of risk on? Where do we rely on qualified people like engineers in that work, and where do we have to belt and suspender and look at every single line of it and double check it as government? How does that play together? And how does this address multiple requirements so that we can respond to the very real question of if you're interested in the environmental outcome, why do you need multiple layers all asking for the same pieces of paper, the same bits of information in order to get there? So here's a place where I think engineering could very much help, but like I said, 2015 is not that far away. Lots to be decided, and a lot of technical input into that conversation would be useful. So let me close by sort of a bit of a summary, my own version of the 3 points around what I think my advice is to when I talk to engineers within government, when I talk to policymakers within government, and when I talk to people outside government in terms of how to influence where this engineering public policy link could happen. You've heard it a number of different ways in the last few speakers, but integrative thinking. In an environmental world, that's an ecosystem perspective. It's not, you're not just an acoustical engineer, you're not just a bridge builder or whatever the type of engineering it's done. It's integrating across the engineering disciplines and integrating with other disciplines to answer those questions and to think of the solutions in that way. Because you could be exactly right, but if no one can see how your piece fits in with the other pieces, they're going to go for the puzzle over on the left that seem to integrate better, because the timings are so tight, the challenges are so great that a perfectly brilliant idea that doesn't fit with any of the other ideas is not a good idea anymore. So integrating the thinking, being able to see the connections, showing how that engineering can drive innovation and link in with other public policy or public interest objectives is really, really critical to the debate, I think. The other one is earlier involvement. I think engineering tends to get involved and the associations tend to get involved when we get to implementation. Increasingly in a preliminary context, that's too late. Because if you look at the way the policy gets developed, if the policy becomes more technical, if the policy makes choices that then limit your options later on implementation, you've missed your window. And I think this is uncomfortable for engineers to get involved that early, because I go to a lot of meetings and the engineer in the room sits there and listens. And all the policy people are just talking away and they got tons of ideas, and the engineer's like, you could tell they're interested, they just don't know how to get involved. And I think finding a way, and maybe it's the point made earlier around communicating your narrative, but finding a way to articulate what is important from an engineering perspective to the debate early on, and that doesn't mean bringing out the diagrams and all the different ways you could fix it, but being able to talk at a higher level about why the technical side matters is incredibly important. In the case of green energy, it was conversations with engineers, both inside government and outside, that helped explain that the noise you get from a rooftop solar system is negligible noise because of the way AC/DC power is done and the way the inverter is related to the whole makeup and where it's located in relation to this matrix of of solar panels placed on the roof is the reason that it was those technical discussions that eventually influenced government to not regulate, from an environmental perspective, the location of solar panels on rooftops. That was entirely a technical conversation. If we hadn't been talking to engineers, it would have been, well, we're regulating solar, we're regulating it everywhere. It's all the same, it all has the same impact, and we're going to put it through the same lens. And every time we look for a way to streamline requirements or make them easier to understand, it's because, in my opinion, it's because technical evidence has come to the fore in a way that's clear and understandable to show us that we can get our environmental outcomes without the same technical process. And so trying to find a way to engage and articulate that earlier without scaring everyone off with the technical conversation, I think is a really important thing to tackle. And finally, I think we all need a more client-focused approach, and I use client in the broadest, kind of balk at the stakeholder word, and I haven't found one I like better, so I'm trying out client right now. But the idea here is that we need a lot of broadening of the conversation, multiple viewpoints, and I find that sometimes in my interactions with engineers, they would say that we're watering down the evidence or the science to have the politics conversation. And I would argue the politics conversation is part of it, and I think you heard that this morning. It's just a different way of saying the same thing. I think that engineers have to come into those conversations respecting the less technical viewpoints, because they all have influence in the decision, and trying to find a way to be a partner in that dialogue so that it doesn't become, well, you could talk about you know, science, or you could talk about political science. They're all part of it, because when you look at public policy and decision making, it doesn't happen in isolation. It is the combination of those two things that's driving the agenda today. So with that, I'm going to move it to questions.